And so we confirmed this on our graphing calculator that, yes, it's the cosine of 3x, but then we needed that 3 there as well. So, all right, the line. What this has to do with is actually a composition of functions, okay? So by a composition of functions, I mean that f of g of x business. Remember when we did that? Because really what we're doing is we are putting another function into the sign, and the function that we're putting in is 3x, okay? So if I wanted to, what I could write was that f of x is sine of x, okay? And g of x is 3x. So then, wouldn't f of g of x be the sine of 3x? Okay. Are you following me so far? That really this is a composition of functions? Okay. So you might not know this, but when we've been doing derivatives before, you might have heard me say with respect to x, the derivative with respect to x. And so when we've been done, it's because we have been using a variable that's just an x. And really, the last thing I do is I say with respect to x, because what's the derivative of x? 1, right? So I don't go around multiplying everything by 1, but that's really what's going on. I'm multiplying by the derivative with respect to x. But no longer is what in here is not just an x, it's a 3x. So what is the derivative with respect to x of that? It's a 3. And so what I'd have to do then is I have to multiply this by 3 because the derivative with respect to x is 3. Okay, so let's then really get into what the chain rule is. Okay, so first of all, we're going to use it. I just gave this trig example, and what we're going to go through in the next few days there's a lot of different chain rules because we've studied a lot of different functions. Okay, so anytime when I'm applying a differentiation rule to something other than the variable that I'm differentiating with respect to, okay? And so sometimes it might be another entire type of function, and sometimes it just might be like we were just looking at, instead of an x, a 3x. Okay, and so for instance, when d dx sine of x changes to d dx sine of 3x, like I just showed you, okay? So what the chain rule then really says to do, and I'm going to write it this way and then I'll carry it on the other side, is it's almost like, I'm going to pick another letter, u, okay? What does u equal though? Careful. 3x, okay. Okay. So what's the variable here in this problem now instead of x? U. Okay. So if I said, hey, what's the derivative of this, you would tell me it is cosine of u times the derivative with respect to u, okay? But now let's go down here. Oh. If this is u, what is the derivative of u? If this is the function u, what's the derivative of u? 3. Okay, so subbing it back in, it's kind of like a substitution thing. If it was a variable, a single variable, we are good with, we know it's the cosine of u, but we're going to put that with respect to u there. Now we're going to sub our things back in. So in place of u, this is cosine of 3x, but what's the derivative of u? Times the 3. And we would write that 3 out in front. Okay. So before we get into memorizing the chain rule, I'm just trying to get you to wrap your brains around what it really is. Really, that extra part comes from the fact that it's another function and I have to find the derivative of that other function when I'm doing 2 rules essentially, okay? Because I have 2 rules going on. I have the trig rule, and then this is a power rule, right, when we bring that power down? Okay. All right, so let's take a look. So one way of thinking of it is this. This is the way I just showed you. If I want to find dy dx, what I do is I change it to a new variable to make my 2 functions. So I did dy du, but then I have to multiply by du dx. Or this might make a little more sense to you, okay? Some people like to call this the outside-inside rule, okay? So in this function isn't the outer function f. So you have to take the derivative of the outer function first. I'm going to just cover that up. Notice, do I change the inside at all? No. So when you do the outer rule, you don't change what's in the parentheses at all. But then you have to multiply by the derivative of what's inside. So some people find this part easier to remember, okay? So the outer, inner rule, inner. Okay, so on the outside, we don't change this, but then at the end, we have to take the derivative of what's inside. Okay. So before I do this one, let me do a reverse of what I just did. Like I did a sine of 3x. I'm going to just do one example the other way. So what if I had cosine of x then raised to the 4th power? And I said find the derivative of that. Okay, so first of all, can you guys tell me what's the outer function? The thing to the 4th power, right? And so that rule means we bring the 4 down and we reduce the power by 1, correct? Okay, and so when I do that, I'm not going to change this at all. I'm going to leave that the same. So I bring the 4 down to the front. I leave this as cosine of x. But now it's to the 3rd, so this is the outer, so I didn't change. But now I have to take the derivative of just what's inside. And what's the derivative of cosine? Very nice, negative sine of x. And so if I wanted to rewrite this, I could write it as negative 4 sine of x times cosine of x parentheses cubed. Okay, now here's where I want to kind of give you an error alert or just a reminder. Do you remember how our book last year and our book this year likes to write this as cosine that like that? So just be careful if it's easier for you to write it in that way so you see the rule. So if it's a trig and the power's right there, really what that means is it's around the entire bracket. Yes, Abby?
Both of them are excessive rotation.
They are both. So if you wanted to write this, by the way, in that way, this is just another way of writing it. Okay? So either of those is fine. Okay, so I'm gonna